longer to do. So we want to look at velocity time graphs. Got it? Okay. Velocity time graphs, and we want to look at what does the slope mean, what does the area under the curve mean, and all that kind of stuff. What each of those graphs is. Now these are more complex than the distance time graphs that we did on Friday. Okay, so we're going to look at those three areas, but first, before we do that, I handed back all the assignments, unless you're handing it in today, which is fine, but then I'll get them back to you sometime today, probably, or tomorrow. Most people did really well in that, in the sense that nobody was really low. Okay, I'll add two. You can add two on that. Okay, so what we're going to do then is just look at yesterday's, or Friday's, pardon me, look at that distance time graph first, and then we'll go into looking at velocity time graphs, which are the more complex ones of the two because they have two different meanings to them, or three different meanings to them. Okay, so let me just back up here. Okay, this is the graph that I gave you the other day. I redrew it here. Okay, and we're looking at calculating our velocity, or sorry, this is distance, not velocity. Here we go. So we're going to look at taking a look at what's this velocity, what's this velocity, what's this velocity, or speeds, and then the average velocity. So first thing we can tell with B is this is 0 meters per second because it's flat. There's no rise. So you don't even have to calculate that one. You can just kind of look at it as well. The other thing is, for your average velocity, you can see you started at 5 and you finished at 5. So you basically went all the way up to 20 and then all the way back to 5. So your basic average velocity or average speed it was 5 minus 5 over 14. 0 minus 14. So that would equal 0. Okay, because basically you didn't move anywhere. You came back to where you started from. So those two are pretty easy. A, if we're looking at A, we rose from 5 to 20. So 20 meters at 4 seconds and 5 meters at 0 seconds. So that would be 15 over 4. Okay, so divide 15 by 4. That'd be equal to 3.75. Okay, and then this one here, we're going downwards. We start over here. We went from the 9-second mark to the 14-second mark. So we had 20 meters at 9 seconds minus 5 meters at 14 seconds. Okay, so this would end up being 20 minus 5, that's 15 meters at negative 5 seconds. Okay, and then just divide 15 by negative 5. This is seconds here. So that's negative 3 meters per second. So that was on Friday. Okay. In terms of difficulty, the distance time graphs are very straightforward, very simple. Just looking at slopes. Any questions about that before we roll ahead? Okay, so today we're gonna, probably today and probably tomorrow, we're gonna flip ahead here. And we're gonna look at velocity time graphs or speed time graphs. Okay, and we're gonna have negative and positive values in these, okay, as well. So we're gonna look at the meaning of slope first. So if we just look at a sketch of a graph, doesn't have to have graph paper, but if I just sketch a graph here, we'll just use red here, and we'll say that's our velocity, this is our time. Okay. So now we know that velocity has direction, so we'll say meters per second north. Okay, and then we'll say, okay, well, what's this down here? This will be our time. And this will be in seconds. Okay, we won't mark anything on it. We'll just draw a basic pattern here, and we'll look at what everything means. So let's say that we start at 0 meters per second down here. Let's use a blue line. And we draw, or let's use a solid blue line. And we go up to some speed, and then we go constant velocity. Okay, and we'll say that this particular spot right here, let's say that we have a time there, and then we have some velocity there. So let's say that this is 20 meters per second, and that this is 0. Say this is 4 seconds, and this looks to be about 10 or 12, let's say 10. Okay. If we do the slope, this equals rise over run. So let's just do the slope of this rising section. We'll call it section A here. So this is just rising up 20 meters a second in 4 seconds. Now you'll notice that the seconds are both on the bottom, so we get 5 meters a second squared. So this is an acceleration unit. Okay, so that's telling you that you're going 5 meters a second faster every second that you go. You're speeding up. You started from 0 and you went up to 20. So your average acceleration would be 5 meters a second because you did that for 4 seconds. And then you stopped accelerating and just drove a flat 20 meters a second for the next 6 seconds. So this part here would be 0 meters per second squared. So the slope of course, this is north. Right? The slope of a V versus T graph is acceleration. Or if you slow down and you go downwards, deceleration. Right? Now the interesting thing about a graph like this, a velocity time graph, is that if you multiply meters per second times this axis with this axis, you get meters. So if you do the area, you actually get a distance, or a displacement in this case. So multiplying, or area, gives us a displacement or distance, depending on if you have a direction or not. Okay, because that area, so if we look at this, so let me just shade it in here. If we look at this area here, this whole area, this represents a distance traveled in 10 seconds. Or in our case, a displacement because we're going north. Okay, so if we wanted to figure that out, we could get the area of this, let's call this okay. So the area of a triangle, if we get this area, it's base times height divided by 2. Okay, in our case, our base is from 0 to 4, and our height is from 0 to 20, divided by 2 for the formula. So that's 4 divided by 2 is 2 seconds times 20. That's 40 meters. So this object, as it accelerated from 0 to 20 in 4 seconds, traveled 40 meters ahead, or north. Okay, this one here is just a rectangle. So a rectangle is just length times width. The length here is 4 to 12, which is 6 seconds. And our height is, again, 20 meters a second. So that's going to tell us that between 4 and 10 seconds, when this object was traveling 20 meters a second for that many seconds, you just multiply the two to get 120 meters forward or to the north. So the total distance of this object would be 160 meters in the 10 seconds that it traveled. Okay. So slope is our acceleration, how much you're speeding up or slowing down. And area is how far you've traveled ahead. Now, there's something a little bit tricky. Some objects will oscillate back and forth, like a pendulum and things like that. So you can actually have distances being measured, but displacements being 0 as they return back to where they came from. So you can get different speeds and different velocities, just like we did in our two-dimensional graphs on Friday. Or no, sorry, on Thursday, I guess it was. Okay? So that's the basics of a velocity time graph. Slope is acceleration and area under the curve. Now, one thing students will sometimes they'll if there's a line here, this is not the curve. This is just a reference line to where it is, right? The actual line is that one and that one. So it's just under the curve. Now, sometimes the graph might dip below the 0 mark and go backwards, might go south. So then you can have negative numbers as well. So that's where you can get into the point where distance can be calculated as well. So distance can be calculated on a velocity time graph. Okay, and when you do this, you ignore direction. Now, what we often do in physics is we often assign two directions, positive and negative. And then we just use algebra rather than saying north and south. Okay? We often just go with positive and negative values. Okay, so distance can be calculated on a v versus t graph by ignoring direction. Displacement must include direction. And we'll do an example like that. Okay? And then, of course, acceleration is just slope. So you can get distance, displacement, acceleration, and also the instantaneous velocity by just reading the graph. So there's a lot of information that you can get from velocity time graphs. If you're given an object velocity and time graph and distance time graph at the same time, there's quite a bit of analysis that you can actually do. So what we're going to do is we're going to do an example problem, one that is going to have some negative and positive velocities in it, and we're going to look for total distance traveled and total displacement at the end of the trip. So we're going to make a trip based on looking at a graph, and then we're going to analyze it. And how we analyze it, it doesn't get any more complex than just doing slopes, areas of triangles, and areas of rectangles. If we had a curved line, we'd have to use some calculus. Okay. Now we don't have calculus in our repertoire, in our math repertoire at this point in our careers. So we then just can do only straight line graphs. So if we had curved graphs, we could take derivatives and integrals and things like that and figure out areas under the curve. If you take calculus next term with me, we will actually do that. We'll take velocity graphs and figure out what their distances are by doing integrals. So that's something that comes up in higher level math later on if you're going into universities where you're going into the sciences. You might want that. All right, so let's do a simple example or two here. Okay, I'm going to use some graph paper just so that I can mark it out and that I don't have these side lines in here so people don't get confused. This is just a sketch, but I'm going to do an actual graph. So let's pop this to the next page and we'll do an example. And this is our major concept for today. So this is something that I asked 2 or 3 questions about on the second hand. So this would be an example of calculating 1, acceleration, comma 2, I don't even know if it needs a comma, just probably the 2, distance traveled, and 3, displacement of the object. From a graph. Okay. Now I usually for areas, some people use letters, some people use Roman numerals. I usually use Roman numerals. So let's put some graph paper here and draw an example for us to look at. We'll use medium graph. Okay. Okay. I'll put my face over on the other side here so that I can make a nice, fairly big one. And we're going to do a t-graph with positive and negative values. So I'm going to go down with a solid line here. Sorry. Okay, and I'm going to go in the center here. Okay, and then we're going to mark and label this graph up. So we're going to do a so this is going to be our velocity on the horizontal. All right, so there we go. Just setting up my screen a little better. Okay, so let's go with blue here. We'll say that this is a velocity in meters per second. Now we'll consider this positive and this negative. Okay, so we won't go north-south, we'll just go plus minus, okay? Okay, so 1, 2 up, we'll go 10. 1, 2 up, we'll go 20. And we'll go up to 30 meters a second. And then we'll go downwards, 1, 2. 1, 2. And then 1, 2. Okay, and then we'll just do seconds in here. 2, 4, 6, 8, 10. We'll go up to 14 seconds down here. Okay. Now we'll make a pattern. We'll have our object start at some velocity, move forward, and then slow down and go backwards, or start reversing. Okay. So let's do that in a green line. Again, because we don't have calculus in our repertoire yet, some of you will later on. Let's just use a green line. We have to use just nothing but straight lines so that we get squares and triangles. So let's start at 20. Let's draw a straight across to 4 seconds. Okay, and then we're gonna go backwards and start slowing down, decelerate. And we're gonna decelerate all the way down so that this crosses the line and it goes down to negative 25 at 11 seconds and it crosses the axis at 7. Okay, oops, let me get that perfectly straight here. So like that. Okay, and then we're going to draw straight back up to 14 so that we actually stop. After 14 seconds, we'll stop our motion. Okay, so what happens is you're driving along for 4 seconds, then all of a sudden you start decelerating, hit the brakes. Okay? At some point here, you start going backwards because you got it in reverse. It's like jamming your thing in reverse. Oops. Okay, and then you keep going backwards. And then at some point, you just all of a sudden jam it into forward and start accelerating again. So driving like, you know, not treating your transmission too good, actually. Okay, so the idea here, let's label up let's say find the acceleration of, let's say, section A, which we'll say is this downward one here. And then find the total distance of the trip. and then find the total displacement. Okay, so we're going to just analyze. Okay, the easy one is to do the slope for section A. We have a starting point and an end point. So we can just go, and we'll do it above here. Actually, we'll do it over here. So we're going to get the slope of this. There's our starting point, there's our end point. So we're going to start at 20 meters per second. At 4 seconds. And we're going to subtract negative 25 meters a second at 11 seconds. Okay, and that's how we do our slope. We have to be careful with signs because of this is below this is going in the negative direction or backwards. We can call this forwards and backwards if you like. Okay, so then we're going to go 20 meters a second, subtract negative 25, that's like adding. So that's 45 meters a second. Over 4 minus 11, which is negative 7 seconds. Okay, then we just divide the two. What's 45 by 7? 6.4 negative. Okay, and it's meters per second squared because those are both on the bottom. Okay, so let me get that a little neater, please. I'm sorry about that. Meters per second squared. So that's our acceleration. Very similar to what we did with the other graphs. Okay, now to find the total distance and displacement, we need areas. Now, the area under the curve is this part and this part. It's not this stuff here. Okay, so you're always, when you're doing area under the curve, the important part is you're always taking the space between the graphed line and the axis, and the x-axis. It's always between the x-axis and the graphed line. So don't go in here, just this here stuff. And don't go up here, just this here stuff. So you're always going between the x-axis and the graph line that's on the page. So right here and right here. Now, in order to get this is a square and a triangle, a triangle and a triangle. So we'll split it into pieces. So I'll just use a regular dashed line to split it into pieces. Here. Okay, I'll use a different color so that it's not the same as the graph. Cut it there and cut it here. That gives us 4 pieces to calculate. Okay, traditionally I just do it right in there. So I call this one 1 and this one 2 and this one 3 and this one 4. Okay, so our first step when calculating displacement or distance is to cut the graph into areas. Find area pieces. Okay, so this one is just a square, length times width. So it's 20 meters per second high times 4 seconds. Okay, so that is 80 meters. Okay, this is a triangle. Okay, it is 20 meters a second high times, okay, it goes from 4 to 7, 3 seconds, divided by 2 because it's a triangle. Remember, triangles are base times height divided by 2. So you have to take half for a triangle. Okay, so we've got 20 times 3 divided by 2, so that's 30 meters. Okay, now this one here is another triangle, another triangle. So this triangle has a base, it goes from 7 to 11, so that's 4 seconds. And it has a height of negative 25. Okay, and it's a triangle, so we're going to divide by 2. So this one is going to be 4 times negative 25 divided by 2, or negative 50 meters. Okay? And we've got the last triangle here. Okay, this one goes from 11 to 14, that's only 3 seconds. Okay, its height is the same height as the other triangle, negative 25 meters per second. And because it's a triangle, we have to divide by, oops, that's not very neat. We have to divide by 2. Okay, so we've got negative 75 divided by 2, which would be what, 35.5? 37.5, negative 37.5 meters. Okay, so now you've got, during this section of the graph, he traveled 80 meters forward. During this section of the graph, he traveled 30 meters, forward. Then during this section of the graph, he went 50 meters backwards. And during this section of the graph, he went, or she went, depending on who's driving, 37.5 meters backwards. So once you've got the area of the pieces, distance is just the total area without sign. So for distance, add everything up, ignoring sign. Displacement, add everything up with sign. That's the difference between the two. So for distance, so total distance, okay, total distance is all pieces with ignoring the sign. Because whether you go backwards or forwards, you're still covering some length of travel, right? So in our case, it's going to be 80 plus 30 plus 50 plus 37.5. Okay, so what do we got? We got 80 plus 30 plus 50 plus 37.5. So we have a total of 197.5 meters. So if you he drove forward so far and backward so far. So that's how far he would completely travel distance-wise. Now for displacement, we just add everything up where we keep the signs in there because that indicates whether he was going backwards or forwards, north or south, depending on what the graph says. So for displacement, add with the sign, because that tells you how far from the beginning you are. Okay, if you started, he actually started at some point We don't know exactly where. It doesn't really say. It just tells how fast he's going. So in our case, that's going to be 80 plus 30 minus 50 minus 37.5. So that's going to tell us, did he end up behind the line or where he was or ahead of the line? So we go 80 plus 30 minus 50 minus 37.5. And we find out that he's 22.5 meters forward. Now, traditionally, when we do this in physics, we usually use positive as forward and negative as backward. But some graphs will have north, south, or east, west in there. Okay. So there's a little bit more to the distance displacement calculation than there would be when we're just doing a distance time graph. A velocity time graph can show you more information, and they often have a positive and negative side to them. Can you have negative time? No. Okay, they haven't figured that one out yet. There's virtual, negative time really hasn't really happened yet. All right. So let's take a look at our outline here, what we're looking for. Okay, so area under the curve, that's distance or displacement. Slope, that's acceleration or deceleration, depending if it's negative or positive. And we did some examples. So I'll leave you today with a graph to work out, and then we'll start next period by analyzing that graph, just like we did this one. So let me flip ahead, and I'll draw you a second graph to look at. We got about 20 minutes left. Should only take you about, 10 minutes or so to draw it and do it. So let's just put some graph paper out. Okay, try this one. Okay, so I want you to find the total acceleration, or the total distance can't type here today. Okay, the total displacement and the section with the greatest positive acceleration. Okay, so I won't give you a letter, you just find the section that has the greatest positive acceleration on the graph. Okay, so let's draw our T. We'll do a T1 here again. So let's take here, I'll use black for the T graph. All right, so go down this way. We'll go out there. Okay, so this will be 0. And we'll count 2, 4, 6, 8, 10, 12, 14. We'll go up to 16, and this will be time. Okay, and this time we're going to do we'll still do seconds. It'll be easier. And we'll call this our velocity in meters per second. This will be our positive velocity up here. This will be our negative velocity. Okay, so we'll go 20 and 30. Or sorry, 20 and 40, pardon me. Counting by tens here. Okay, and then we'll go negative 20, negative 40, and negative 60 down there. Okay, we'll start our trip, and we'll do this in green. So let's start at negative 60. Go up to negative 10 at 4 seconds. Okay, and then we'll go straight across to 8. Then we're going to go straight up to positive 60 at 15. Okay, so that this little half a square here. Be careful about that little piece there. Okay, so this stops at the 15 seconds mark here. Okay. Okay, a little bit of a trick here I'm going to mention to you guys. Okay. This triangle, there's a square here and a triangle on top of it. So don't forget there's this rectangle here. Right? That's one big rectangle you have to do. So when you cut it, I will help you a little bit with this one. Cut it like this. Okay, because there's that square laying on top of that. All right, I'll let you work that through. That's it for instructions today. Okay. And presentation and all that kind of stuff. So we'll start next period by working this out. I'll stay online for a couple minutes here, but I'm going to log out at 10:02. And I'll stop the video at this point as well.